Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hello and welcome back to this amazing channel which is Geeks for Geeks Practice. Myself Abhinav Awasthi, and today we are going to discuss the new problem of the day, which is minimum number of coins. This is the problem of the day for 6th of November and we are going to discuss it. Okay. So first please hi Joel, hi Subham, hi Spurs. Sure. So basically, why we play these ads or these intros, it's because that you guys get these notifications something late. So you guys require some 1 or 2 minutes so that everyone can join to the live. So we have to take a 1 minute of gap before starting the session, and so that YouTube can send notification to everyone. Until that, we will have this intro part. Okay. So that's the actual reason why I basically run these intros or ads in this particular thing. Okay, so that's the reason actually. Great guys. So yeah, now great, let's start with the case, which is nothing but today's problem. Okay, can anyone guess me that on which concept or on which topic this problem is based? Co- on which concept or in which topic this problem is based? Can anyone tell me? No, not greedy. It is not based on greedy. No. Just tell me the algorithm or the concept on which this problem is based. There is a very basic algorithm, a very common algorithm, which is very important, which is very famous. Can anyone guess that? क्या है वो चीज जो यहाँ पर लग रही होगी? नहीं, sorting तो नहीं है. No. It seems to be that, but it's not sorting. Think of it. Think of it. अच्छा we अच्छा नहीं, not binary sets. DP. अच्छा okay, DP. It's DP रुचि. Fine. बट डीपी के आगे भी क्या? अच्छा पहले लाइक कर दो, जो लोग भी आ रहे हैं लाइक कर दो, ठीक है? तो वो लाइक मैं क्यों बोलता हूँ करने को, क्योंकि थ्रू लाइक वी गॉट अ रीच हो जाती है और लोग ज्वाइन करते हैं. नो, इट्स नॉट बाइनरी सर्च. नो, नो, it's DP. Okay, it's confirmed my side. It's DP. अच्छा, so लव यू प्रो सारे टॉपिक्स बोल देंगे. बाइनरी हो गया, हैशिंग हो गया, अब क्या बचा? टू पॉइंटर्स बचा, सॉर्टिंग बचा. नो, so it's DP. Okay, it's dynamic programming. But can we go more deep कि डायनेमिक प्रोग्रामिंग का कौन सा टॉपिक हो सकता है? विच टॉपिक ऑफ डायनेमिक प्रोग्रामिंग? विच एल्गोरिथम, विच कॉन्सेप्ट? नो, नॉट स्टैक. अच्छा अच्छा अच्छा, let me give you some hints. What is given in this problem? Okay, we have a value 0 1. Okay, not 0 1, something. Okay, let's say if you have a, what is given to us in this knapsack? Exactly, yeah. It's great. Yeah, you are pro. You're actually pro. No, not Karane. Karane is greedy actually, Gaurav. Knapsack. So we will use unbounded knapsack here. Yeah, bottom of DP, top down. So okay, that is the approach of DP. I was talking about algorithm. Knapsack algorithm includes excluded. Yeah, and here we are not just 0 1. 0 1 means either take that, either not take that. But here we have the unbounded knapsack also. Unbounded knapsack. Okay, let's see how we will do this thing. Okay, let's see this thing. Okay, so guys, okay, if you are joining here, please don't leave for the next half an hour. Okay, because I think that if you will continue with this stream, you will learn something new today. Okay, great. So let me first share the screen. Okay, first let me confirm key. Yeah, everything is fine. Let's share the screen. Great guys. Okay. Okay. So if same as Yeah. It is same as coin change. Let's see what it is given to us. Okay, let's see this thing. It is saying that we are having, we have to find minimum number of coins. Okay, we have to find minimum number of coins. So we have the infinite supply of denominations of Indian currency. We have a 1 rupee coin. Well, to be honest, I've solved this problem using greedy, and I've used in the past. I have solved it on coins in Eurozone. Okay. Uh, okay. Uh, maybe Subham, this problem can be solved using greedy, but actually, if I will tell you, this is a classical problem of knapsack. Okay, so it's fine. Okay, yeah, congrats. Yeah, so yeah, we have infinite supply of some denominations of coins given to us. We have a 1 rupee coin, 2 rupee coin, 10, 20, 50, 100, 200, 500, 500. Okay, we have to find minimum number of coins needed to make the change for rupees n. You must return the list containing the value of coins required. Okay, you have to return the list of value of coins required. Okay, and these are the denominations which we want. Okay, okay, fine, guys. Yeah, it's fine. So let me tell you guys how we can solve this problem using greedy also. Okay. Acha. So, okay, if you guys have solved it, let's solve this using greedy. And I'm getting it on now, how we can solve it greedy too. Okay. There's a very basic variant of this question, which is nothing but coin change, which is here. This is a problem, guys. This is more of that dynamic programming approach. Why? Why this is more of dynamic programming? The reason being this particular problem here, there's a difference between this problem and that problem. Can anyone guess me the difference? Can anyone tell me the difference? That why this problem can be solved using knapsack but can't be solved using greedy, and this problem can be solved using greedy. You will also see the tag. Yeah, that is greedy also. So let's solve it using that only. Don't, let's not make it complex. But if can anyone tell me that what is the difference between these two problems? Here also we have an array of coins. We want to sum up to the sum. We have the infinite supply of that coin. It's same in this case also. But why this problem can be solved using DP only and that can be solved using greedy? Can anyone tell me? Exactly, Subham. Exactly, you've got it. So what is given to us in this problem? Okay, the currency is already given to us. Means what currency we can use? It is already given to us, which is this 2,500, 200, 150 or different. But in this coin change problem, currency is also based on the test case given to us. It is based on the test case which is given to us, and that is why the thing which is want there is the count of the coins, that how many minimum coins are required, or basically they are wanting as the number of ways, not the minimum coin, number of ways. It's something similar to that. But here what is we are wanting is, here we were wanting the minimum number of coins. We use knapsack to maximize the profit. We can use that here also, but it's quite different from it. I've given you an example of knapsack because knapsack problem is also similar to this, and there's a variant of this problem which is solved by knapsack. The only difference between this and the variant is in this problem, the coins, the array of coins is fixed. But if let's say that the array of coin is not fixed, it is different for every test case. So in that case, we will use the knapsack only, or you can say DP only. DP is the only way to solve that type of problem. Is it clear to everyone? Is this thing clear to everyone? Just write a one. Just write a one. If it is clear, just write a zero if it is not clear. Okay? Hello, Nakaj. Okay. And yeah, for those who are saying greedy, yeah, we can use that too. Okay, Kamran Ali and Asu Sana. Okay, let's have it again if you are not understanding. I am saying we have two different problems. Let's just assume a scenario, okay, that we have two different problems. Yeah. No, that is also fine. You see that in that we are asking number of ways actually. That is why DP is there. Let's take a case. Let's take a case. Okay. The case is, let's say key the coins. Okay, let me explain you it with the example. Okay, let me explain you this thing with the example. Okay. So see one thing. Here it is saying that currently our denominations are like this. This is the range which is given to us. Which is fixed for all the test cases. Which is fixed for all the test cases. So for all the test cases, these are the only denominations that we have. Let me add the title in the banner. Okay. Now, guys, if you will see one thing, let's say I want 8,353 rupees, and you have to minimize the number of coins or number of notes basically. So first of all, you will try that I will take these notes. So you will say that yeah, take this note. So it will be 2,000, 2,000, 2,000, and 2,000. Now how much is left? 353 rupees is left. Then you will say me that take 200 rupees note because 500 is greater than it. So 153 is left. Then take a 100 rupees note. 53 is left. Then 50 rupees note. Then 2 rupee note and 1 rupee note. Is it maximum? Minimum, right? It is minimum. Okay. But let's take a case. Let's take a case, guys. The case is very simple that let's say this 1, 2, and 5 is not given to us. So what will be the minimum number of coins in that case? Or let's say a different example. Okay. A different example is something like this. Just give me a minute. Okay. Let's say this is the example given to us. Okay. And the value which is given to us is 20. Okay. So this is the, please guys, please try to understand. Okay. It's quite complex. Then you will get it. The value given to us is 20. Means we want sums which will sum up to 20. If we will apply the greedy technique here. So see one thing. Yeah. We can't take 2,000 rupee note. We can't take 500 rupees note. We can't take 200 rupees note. We can't take 100. We can't take 50. We can take 15 rupee note. So according to greedy technique, what we will do? According to greedy technique, we will simply take this 15 rupees note. Okay. So this 15 rupee note will be taken by us. How much is left? Please write in the chat box. How much is left? 5 is left. Now you can see that we don't have any 5 rupee denomination. So greedy will give you wrong answer. It will say that you cannot sum up to 20. But actually you can using 210 rupee note. That means you have to check for every possible solution. And whenever the case of every possible solutions, number of solutions, this comes, you will use dynamic programming. But here you have your denominations ranging from 1 to 2,000. Means the minimum denomination is 1 also. So that means there will not be any case that you will use any, that it is not possible. Now let's see how you will do this. So let's say this is the case that you have. Okay. So if I will take this range only, you can easily solve it using the greedy technique. That is why I was just strict. Okay, I was just strict with the question. I was just making you guys a check Okay, in start, I will truly say that I was just gone towards that problem because that is the problem which I've solved using DP knapsack. But yeah, thanks for you because it is can be also solved by greedy. Okay, exactly. And I have basically solved it using knapsack only. But yeah, it can be solved by greedy. Exactly. It's a greedy one also. Okay, great. Fine. So let's say the case given to you is okay. Why you have removed your comment, Joel? I was just taking that it was 8338 now. Or let's take a different one. Let's take 8 7 5 8. Yeah, we can say it. We can say like that because one is present. Understand? So it will never be the case that solution is not possible. Also, it's not only that they say that one is present. No, that is the one condition. And because one is present, so we are okay. That solution will always be possible. That's the first thing actually. There is one more thing why we are using greedy here. The second thing is it is just wanting from us minimum nodes. Obviously, to make minimum nodes, and we know that solution will be always possible. Solution will be always possible. You will see. It will be always possible. Always. You can't get me any number for which solution is not possible for this test case. Just give me a value. Claim me a value key for any value if solution is not possible for this array. It is always possible. So what we will do, we will start from back of the array. And if that number is less than the required number, less than equal to the required number, we will take it. So it is 8758. Okay, so let's say that the value n is 8758. Okay, 0. Subham. Acha, okay, you are saying 0. So if it is 0, so obviously 0 means no nodes, then also solution is required. Okay. But we are assuming value is greater than or equal to 0. Okay. So first we will take 2000 rupee note, 2000 will be taken and subtract it by 2000. Remaining is 6758. Similarly, okay, 0 is there now. So 0 is there, it's fine. It's starting from 1 there. It's starting from 1, not 0. So it is 4758. Then again 2000 two times, I think. It will become 758. Then 500 will be taken. It will be 258. Then 200. It will be 58. Then 50. Then 8. Then 5. Then 2 and 2. Then 1. These are the denominations that we have. So we will just go on subtracting the number and then adding that number in the vector. Am I right? Have you guys also solved using this technique? Nakas, Subham, those Risit, those you have solved. Have you also solved using this technique? Is it right? Okay, great. Now let's do this. Okay, let's do this. So first of all, what we will do, we will create a array for these numbers. Okay, so let's have that array. Int, let's call it D. Let's call it D array. Okay. Thanks, Sumanta Kumar Sahu. Thanks for it. Okay. Now the next thing that you will have is nothing but this is the 1, 2, 3, 4, 5, 6, 7, 10. This is a 10 size array. So what you will do, you will simply check for while the number is greater than 0. You will do this. Okay. And initially our iterator will be at the last index. Means here. So now if the number is greater than the value of di, actually greater than equal to. So what I will do, we will subtract the value from it and we will take a vector in answer and inside it in answer we will simply push back it. Okay, we will simply push back the value. Else, if else will be the case, we will simply do I minus minus. Okay, at the last we can return this answer. Oh, sorry. In such problems, can we know that we are applying greedy? Like we have currency, then we have used DP as input, 20 is optimal, values 2, but greedy would give 5. Yeah, exactly. In this, I'm saying na that it's not like ki if one is present there, that doesn't mean ki we will always use greedy. No, no. Why we are using greedy here? The go one present, it means one is present. That means ki solution is always possible. That is the obvious case. If one is present, that means solution is always possible. But it doesn't mean that it will give the right answer. It will only give the right answer when you have the fixed denomination. And the denomination's range is fixed. You will see here. The denomination is something which is 2000 and 500 and 211. Getting? It's like this. Yeah, we won't remember. Okay, guys. So let's first submit it. I have even not solved this problem using technique, but yeah, it has got the right answer. So now you can see one thing that you can claim that thing to me. Let's give me an input. If for this input the answer is wrong. No, it will not be wrong. I've just entered into my second year, so I don't know this technique, but I can solve it my own without caring that. Uh, but you have to care for time and space complexity, Joel. Actually, you have to care for it. Okay, it's not like if you will not care, that will not work. Okay, you have to care for it actually. Okay, one more thing. Okay, this is okay. Let me explain that to you. Okay, let me explain this to you. Fine. If you will see one thing, okay, if you will see one thing, more the smaller values will be, more it is okay to have. It seems it seems very difficult. What I'm saying. First, we have 2000. There, what we have received. There, we have 15. But after 15, 5 was not present. After 15, 5 was not present. Okay, but 5 should be present because if you are giving a 15, okay, which will give you a difference of that. But if you will see here, I step by step follows there. First 2000, so all the value above 2000 will made less than 2000 by taking 2000 rupees coin note. Now, when we will take 2000 rupees note, to, then we have a remaining value which is obviously less than 2000. Then for making that 2000 more or less, we have 500 rupees coin. So 500 will be deleted, subtracted. Now the remaining value will always be lesser than 500. So for making that value which is lesser than 500, we have 200 rupee coin note. Now 200 will be subtracted. Now the value we have is lesser than 200. Now we have 100 rupee note. Now 100 rupee note will be used. Now the value that we have is less than 100. Now we have 50 rupee note. After 50, we have 20, then 10. So a gradual fall is there. It's not like 15, 10, 1. Getting it or not? So this is what you have to observe actually. Okay, when you are so how you will observe? You have to make a check by taking different values. Is it possible or not? Is it possible or not? Okay, yeah, that's what it is. That's what it is. Okay, guys. Okay, I hope it is clear to everyone. This is how we are using it using greedy. If we will talk about the time complexity, so I think this time complexity will be equal to this size of this array only, which is the number of nodes required, because this loop will run that much times only, whatever will be the uh, length of this answer. Okay, great guys, great. So that's what the problem is. That's what the problem is. So hit the like button if you have understand it. Okay, great, great guys, great. Uh, can be optimized further. Fun of the day. Can I use candy? Okay, yes, Subham, you can share your reviews how we can use means how we can optimize it further. Yeah, Subham. It's fine, but there is a thing, Subham. We have to add that to the vector, na. I am known what you are saying that instead of multiplying it multiple times, just make it like this. Int x is equal to n divided by di. And this x number of times that value will be taken, that node will be taken. This is what you are saying, na? I got it, I got it. But but we have to add that to the answer, na? So for adding that value to the answer, we have to take the loop, na? I got it, Shubham. I got it. I got your approach. Let's say I've taken it. But for adding that answer to the, let's say if it is just wanting the coins, how many the minimum coins are there? Then obviously we can take the integer division and modulo. But here we also output the result. Okay, that's what it is. My Sunday become a fun day with your lecture, sir. Arey bhai, thanks yaar. Thanks very much. That's what it is. Now onward is Monday. Monday again, college again, work, सब कुछ फिर से दोबारा से आ रहा है यार. Great guys. Okay. Okay then. Guys, thank you. Let's meet with the next soon with another promoted day. So keep solving the problems, keep practicing, keep exploring. Happy coding. Good night. Thank you. Bye bye.